Hello everyone. I know you're also excited. So we're going to actually kind of build on law of sine, law of cosine, well, mostly law of sine, and we're going to talk about what we call an ambiguous case. So this is going to just kind of expand on what we did in law of sines, but I'll show you what all this looks like. So with ambiguous cases, what this means is that there's actually going to be potential where you're going to have either no solution, one solution, or even two solutions. Now this is actually referring to how many triangles are possible when we're doing the law of sines. And that's why it's going to be considered ambiguous, because we may have potential for either multiple solutions or just none at all. So now, law of sines in ambiguous cases, this is going to be specific to triangles that are side-side angle. Now, of course, be careful how you write it, but you know what? Take your chances. You live, you learn, but you know what? You only live once, so have fun. So then just a final reminder, your triangles are going to have 180 degrees. So that's really going to be kind of a recap review, but also a very important idea for what's coming up. So when we're doing law of sines in our side-side angle triangles, when we're solving for the next angle, we're actually going to have to find the supplement, and I'll show you what all this kind of looks like later on. Or actually, how about right now? So I'm going to move my calculator. Got some paper. So once again, I'm going to do these papers, or not papers, hello. I'm going to do these problems on a separate piece of paper just to kind of give myself plenty of room to kind of work on these. So starting off, we are going to be given that angle A is 40 degrees, side A is 6, and then side B is 8. So I'm going to attempt to draw, everything's fine. So we have an oblique triangle, so I'm going to label A, B, and C. So you can label it however you want. So this is going to be 40 degrees, and then across from it's going to be A, which is, hello, that should be a 6. There we go. And then across from angle B, which is side B, which is going to be 8. All right, so now what we're going to do is we're going to go ahead and just do law of sines to actually solve our triangle and see what happens. So we have a pair of values. We have a big A and a little a, so we're actually going to kind of use those to start off. So we're going to start with sine of 40 over 6 is going to be equal. So let's go ahead and solve for angle B. So that's going to be sine B over side of 8. So the reason I'm starting with B and not C is because with B, I at least have the side, but with C, I have nothing. So I need to start with B to fill in this missing gap. So over here, now I'm going to cross multiply. So I'm going to have 6 sine B. That's going to equal 8 sine 40. So I'm going to divide by 6. So 8 sine 40 divided by 6. And then I need to take the inverse sine of both sides. So this is going to give me B is equal to the inverse sine of 8 sine 40 divided by 6. So now I'm ready to go to my calculator. So that's why I'm doing those on paper, so you can kind of see my calculator. So here's my values from the last video. All right, so on here, so I'm going to reset my calculator again just to kind of be safe, just to kind of rinse and repeat. So I'm going to go back to run matrix. So when you reset your calculator and you're in, your calculator is going to default back to radian mode. So you need to change it back to degree mode. So as a reminder, in order to do that, you're going to do shift, menu, and then you need to go down to angle, and then you're going to press degrees. So I'm going to press F1. Now, if I'm already in radian mode and I want to go back to degree mode, or nope, if I'm in degree mode and I need to go back to radian mode, you can press F2, or you can always toggle back and forth between whichever one you need. But we're going to stay in degree mode. So now that I'm in degree mode, now I'm ready to plug in. So shift sine. So 8 sine 40 over 6. So this is going to give me a B value of 58.98697. All right, now I'm going to kind of pause on this question for a minute, and I'm actually going to kind of expand on another idea. There's a reason for it, I promise. So over here, what I'm going to do is we want to focus on just like the unit circle. So I'm going to draw the unit circle, well, part of it, or none of it, it's fine. So really what I want to do is perfect. So I'm going to start with 30 degrees, and then I'm going to come over here to 150 degrees. So for example, if I do 30 degrees and 150 degrees, so what hopefully you'll notice is if I were to do sine of 30 degrees from my unit circle, this is going to give me 1/2. And if I come over here and do sine of 150, well, that also gives me 1/2. So notice how if I were to evaluate sine theta equals 1/2, we're going to get two different values. Now, if I do the same idea, let's do for, say, 45 degrees. So if I do sine 45, that's going to give me √2/2. And then if I come over here and do, let's say, 135 degrees, so if I do sine 135, that's also going to give me √2/2. So I know this isn't perfect because I'm doing this on paper, but tomato, tomato. So we're going to do one more. So like if I do 60 degrees, so sine 60 would give me √3/2. And then I can also come over here and do 120 degrees. So 120 degrees will also give me √3/2. So what I want you to really take away from this is notice how there's going to be two values that can give you the same sine value, but also notice the types of angles. If I do 30 and 150, those add up to 180. If I do 35 and 45, those add up to 180. If I do 60 and 120, those add up to 180. So this is just kind of a really neat idea to kind of piece together what I'm about to do. So the reason I say that those values add up to 180 is because what you're doing is we're doing the supplement. So this is where that supplement piece kind of comes into play. So like if I got 30 degrees for my angle, I would find the supplement, and then I would also do 150 degrees. Whereas if I got 130 degrees for my angle, then I would also need to find the supplement, and I would also do 45 degrees. And that's because we get the same sine value. Okay, so kind of coming back over here. Go away. So if I come over here, what we also want to do is once we find this first b value, then I also need to do another b value. I need to do the supplement. So I'm going to do 180 degrees minus that 58, and I get 121. So I'm going to get 121.013. Yes. Okay, so now that we have our two potential b values, now what you want to do is you want to check, or actually before that, let's actually kind of prove to see why we're doing this. So on the calculator, what I want to show you is why we're taking kind of both of these values. So if I were to take sine of that 121 that we just did, we get 0.8571. But then if I were to do sine of 58, 986966953, we get the same thing. So this is why we need to take both of those values, because these are both potential solutions. This is where that angle works right here, this angle right here that we just got, it works for both of these. So we have to account for both. So the next thing that we're going to check over here is we're going to look at both of our b values and your existing angle, and we want to see if we have room for a third angle. Okay, so over here, this would be case 1, and over here, this would be case 2. So what I like to do is I like to work in columns. So down here, I'm going to do case 1. So in case 1, what this tells us is that your b value is going to be equal to 58.98697, which means we're going to check to see if angle C will exist. So to do this, I'm going to do 180 degrees minus angle A, then minus angle B, and I want to see if we're going to get enough degrees left over to actually have angle C. So I'm going to do 180 minus angle A, which is 40, then minus angle B, which we're saying in this case is going to be 58.98697. So that means our final angle, angle C, will be 81.0130. So that works. That's 180 degrees. Okay. So now that I have both angle B and angle C in this case, now I need to solve for side C up here. Whoops, can't see. So I'm going to solve for side C over here. So to solve for side C, I'm going to do law of sines. Okay, so now I'm going to do sine 40 over 6, and that's going to be equal to sine 81.013, and then that's going to be over little c. So I'm going to skip a few steps. So this is going to be equal to 6 sine 81.013 over sine 40, which means, in this case, we would have 6 sine, I'm going to recall, 81 over sine 40, which means we're going to get a side value for C of 9.2198. So that would be all of, whoops, you can't see anything, my bad. So this is going to be all for case 1. So what I want you to also kind of realize and notice is that on these problems, we're going to give you space where you're going to have to write out your values for case 1 and your values for case 2. So also keep in mind, at the beginning, we're going to be a little nice. We're going to give you what values you need to solve for in both cases. But then notice on the back how I take away what values you're actually going to be finding. So depending on your level, whether you're on level, AP, honors, whatever. So I know in AP, we may not even tell you if it's ambiguous. So you actually have to write out and determine and prove to us that it's ambiguous. I will say for on level, we're going to be a little bit nicer. We're actually going to write out and keep the ambiguous cases a little bit separate from law of sine, law of cosine. But yeah, for upper level, we're going to kind of mush it all together. On level, we're going to space it out a little bit more. All right, so now that we did case 1, now we got to do the same thing, but for case 2. Make sure to see if you can actually see it this time. So for case 2, so now we're going to take our other b value. So now I'm going to take a b value that's equal to 121.013, and then we're going to solve for angle C. So it's going to be the same logic and same steps that we did over here for case 1. So I'm still going to do 180 degrees minus angle A and then minus angle B. So now I'm going to have 180 degrees minus angle A, which is going to be 40, then minus angle B, which in this case we're saying is 121.013. So in this case, so 180 minus 40 minus 121.013. So that's going to give us an angle. So I'm going to write it over here so I have some room for angle C. We're going to get 18.987 degrees. So it's a small angle, but it's also because angle B over here is a pretty big angle. So with 121, 40 degrees, it's only going to leave us about 19 degrees left to kind of use. So, but it is still a valid case. So now that I have this angle, now we're going to go back and do law of sines to find out what side C would be in this case if it's only 18.987 degrees. So I'm still going to do sine 40 over 6, and then that's going to be sine 18.987 all over side C. So once again, I'm going to skip a few steps. So 6 sine 18.987 all over sine 40. So notice how it's very similar to case 1. We're just kind of changing our values just a smidge. So now for your C value, when you plug in, get rid of all that. Ding, ding. So we're going to have 6 sine of 18.987 over sine 40. If I can type, that would be amazing. So that's going to give us a side length of 3.0696. So 369, I'm going to go ahead and write to 5. That's okay. All right, and then I decided to be nice on the ambiguous cases. I'm not going to make y'all find the area of ambiguous because these problems can already be long enough as is, so we're just not going to do that. All right, so for case 1, so now I'm going to kind of fill in the values. So this would be 58.99 for angle B, and then for angle C, then that's going to leave us with 81.01 degrees, with side C being 9.22. It's kind of muddy because I have to write kind of small, but it's okay. All right, and then in case 2, now you're going to write out, so angle B, which is going to be 121.01 degrees, angle C, which is going to be 18.99 degrees, and then side C, which in this case would be 3.04. So this is the information that we're going to be looking for the ambiguous cases. All right, so now let's kind of jump over, and we're going to now move on to number 2. Oops, need a fresh piece of paper. There we go. All right, now on number 2, so same idea. So I'm going to start with an oblique triangle. Let's see if I can draw one. Ta-da! So now I'll label A up here, B over here, and then C over there. So I like to mix it up just to remind myself that it's all randomized and that nothing is going to be drawn to scale. So when I look at angle A, this is 42, and then side A, which is going to be across, is going to be 10, and then side B, which is going to be 9. So once again, I still am going to have to do law of sines. I have my pair of A's, and then I have a partial of B, so I need to find angle B. So I'm going to start off. Let's do sine 42 over 10. And then we're going to do sine B over 9. All right, and then you're going to cross multiply and divide. Okay, so in this case, when I cross multiply, we're going to have 10 sine B. And that's going to equal 9 sine 42. So then sine B is going to be 9 sine 42 over 10. And then inverse, sine both sides, so inverse sine of 9 sine 42 over 10. Whoops, can't see. There we go. My bad. All right, so now I'm going to come over here. So inverse sine, and then 9 sine 42 over 10, which is going to give me a B value of 37.0289 degrees. So this would be case 1. Now remember, you got to find the supplement in order to find case 2. So over here, I'm going to do 180 degrees minus that value, which means case 2 would be 142.9711 degrees. All right. Now, before I move on, now we're going to go ahead and check the validity of both of these cases before we actually solve for both. So notice how over here, we're going to have 37 degrees for case 1 and then the 142 for case 2. So I'm going to do, there we go. So 180 degrees minus 42, then minus the 37.0289. So in case 1, that other angle would be about 101 degrees. Now let's check case 2. So 180 degrees minus the given angle of 42, and then minus the 142.9711. So notice how that's going to give you a negative angle. So that means the third angle, it can't exist. So what's going to happen is over here in case 1, that's a check. We can have case 1, but in case 2, because we get that negative angle, it exceeds 180 degrees in the triangle, which means case 2, it doesn't exist. So we're not even going to bother with case 2. Okay, so we only have to do the law of sines to find just one case. So over here, now that I have my B value, so I'm going to rewrite 37, that's a 3, 0289. So then I can use that information to find the value of angle C. So angle C is going to be 180 degrees minus angle A, then minus angle B. So 180 minus angle A, which they tell us is 42 based on given, and then angle B, which we're going to use the 37.0289, which we found earlier, which was the 100.9711. Okay, so beep. I swear those bells get longer and longer. All right, where was I? Hello. Okay, so we found angle C. So now I need to find side C. Okay, so now I'm going to go back and do law of sines. So sine 42 over 10. And then that's going to be sine 100.9711 over side C. So you're going to cross multiply and divide, of course, just as you would before. So that's going to be C is equal to 10 times sine of 100.9711 over sine 42. All right, and then you're ready to plug in your calculator. So this is going to give you 10 sine of 100.9711 divided by sine 42. So that's going to give us, well, probably let you look at my calculator, 14.6716. So 14.6716. All right, so now that I have all of my information, I'm ready to come back over here and actually kind of write out my information. So what this should look like, so first off, we can eliminate case 2. So what you're going to do over here is you're just going to slash through case 2, telling me that it can't exist. So I don't want you to leave it blank. I specifically want you to cross it out if it doesn't exist. That's going to be your way of telling me that it doesn't exist. If you leave it blank, then to me that is an indicator that you just don't know what you're doing, which, big mood. But anyways, so big B, which we said is going to be 37.03. Oh my God. And then big C, which we said was 100.97. And then little c, which is going to be 14.67. Ta-da! All right, so we've seen instances where we have 2 solutions. We saw a case where we have only 1 solution, but now I want to show you, I'm going to kind of spoil it, but I want to show you what it looks like to have no solution, which these are my personal faves. So we're going to jump down to number 5, which you can oh so clearly see. So I'm going to save on some paper and I'll just do it on this page. All right, so down here, we're going to do number 5. Or we'll do it this way. There we go. All right, so based on this given information, they're going to give us angle B, side A, and then side B. So I'm going to draw my oblique triangle. Close enough. So let's put A over here, B over here, and C up here, because why not? So big B is going to be 85 degrees, which as you can see, we're clearly drawn to scale. Then side A is going to be 25, and then side B, which is going to be 15. All right, so let's go ahead and start this process. So I have a pair of B's, so I'm going to do law of sines with my B values. Okay, so this is going to turn into sine of 85 over 15, and then that's going to be equal to sine of A over 25. So when I solve, so we're going to get 15 sine A equals 25 sine 85. So I'm going to divide both sides. So we're going to have sine A is going to be equal to 25 sine 85 over 15. And then you're going to take inverse sine of both sides. So 25 sine 85 over 15. And now we're ready for the calculator. So over yonder. So I'm going to do inverse sine, and then 25 sine 85 over 15. Oh, darn. So this is essentially telling you that this cannot exist. So, womp womp. Everything's fine. So in this case, this means that there's no solution. So you would actually write out no solution. So this is what I would look for in the work. But then over here on the actual like answer sheet or on the test, quiz, whatever. So for both of your cases, you would actually just cross out both cases. And then somewhere on here, I would look for no solution to give you credit. Because if you just cross out the problems, I mean, if I don't see no solution, I'm just going to assume you cross out the problems. So I need to see no solution and then that you crossed out both cases. And then if we only have one solution, I need to see one filled out and then that case 2 is going to be crossed out. And if we have 2 cases, obviously I need to see both of those written out. So, ta-da!